Okay, cool. So what we're talking about today are classes and objects, and it's basically the last topic for the basics of Java unit. Okay, so first we're going to start off with like a lesson 2 and 3 recap. Hopefully you guys watched the video or looked at the slides so that you're a little caught up on what we talked about last week. Yeah, okay, so we talked about loops and methods. So loops first. Loops is basically a series of instructions that's repeated until a certain condition is made, right? So last time in English, it's basically, I described it as, let's say you want to draw 100 circles on your paper. You would have to move your hand in a circular motion 100 times until you've drawn 100 circles, right? So the 100 circles is the condition, right? Once you've reached that condition, you don't need to carry out the series of instructions. Like you can stop the loop, right? But while you haven't drawn 100 circles yet, like while you have less than 100 circles on your piece of paper, you want to keep moving your hand in circular motion, right? So that's basically loops. And then like that's kind of how you describe it in English, right? You can carry it across to Java. It's basically just like repeating a series of code a certain amount of times based on like whether your condition is true or false, right? So this is kind of like the structure. So there's two loops that we mainly use in Java, the while loop and the for loop. So the while loop is, I think it's easier to learn just because like the parts are more laid out clearly. So it has a start value, and this is like your control variable. This is what you use to control the loop, right? So let's say you wanted the loop to carry out 3 times. This I here would be used to control how many times this loop is run, right? So you start by creating a variable, which is your control variable. It's your start value. And then I is evaluated in the condition, right? So this is basically saying while I is less than 4, print it and then add 1 to it, right? So you're basically saying if I is less than 4, which means if I is less than 4 is true, so 1 is less than 4, which is a true statement, right? It's going to print I and then it's going to add 1 to the value, right? So now when I comes out of this loop, I is now 2, right? So it's going to go through, it's going to be evaluated here again, right? Since 2 is less than 4, this condition is true. And then this I will be printed out and added. Added to 1 will be added to it, right? So now I is 3. So do you see like this kind of a pattern, right? Every time you go through the loop, it does the same exact thing, except the numbers change just a little bit. And then eventually your condition ends, right? When I is 4, 4 is not less than 4. So this condition is false, and then this loop ends. Stop me at any point if you kind of need a little more review for this, because I'm just going through it pretty quickly. Okay, so it talks about the while loop, right? It's basically carrying it out until this condition is true. And then you can, most of the time in Java, you can transfer the info from the while loop into the for loop, right? If you see here, there's a lot of similarities. So I kind of boxed in the different colors, right? And these are kind of like the same things, right? It starts with the control variable or your start value. The middle is your condition, which is what we see here with the true or false. And then here's the increment, right? It's basically changing the control variable so that the loop eventually stops, right? I plus plus and I plus equals 1 are the same exact thing. I plus plus is generally an easier way to write it. It's a shortcut most people use. Yeah, so you see here, there's a lot of similarities and they have the same exact output, right? So a lot of time when you like learn while loops, you can kind of like practice and transfer it over to for loops, and it prints the exact same thing. So sometimes they're not used interchangeably. Sometimes there are benefits to using a for loop over while loop and vice versa. So for for loops, people usually use it when you know exactly how many times you want to run it. So let's say you want to run the loop like 4 times. You can just change the numbers here and kind of like use math to count out how many times the loop will occur. Sometimes people use while loops here when this condition is not number based, right? It's kind of just like, it's a little more complicated, but yeah, I don't really know how to explain it. It's basically like for loops are more direct. Like if you know exactly how many times you want to run it, you typically use a for loop. If you don't know exactly how many times, it's kind of based on a change in condition, you would use a while loop. But you normally like, once you've used these a lot, you kind of figure it out. Like you kind of are like, oh, maybe it's easier to write a while loop for this instead of a for loop. Yeah, so experience is kind of key to differentiating when you use them, but on most cases, you can use them interchangeably. Okay, we also talked about methods, right? So a method is a block of code that it runs when called. That's like the formal definition of a method. Basically, it's like, let's say you were driving a car and the car's methods are like stuff like brake, accelerate, turn left, turn right. So that's all like 4 different methods, right? It basically it has a certain function, and only when you want it to run, it's gonna call, right? So you don't always want the car to brake. You only want the car to brake when you press the brake in the car, right? That's kind of like calling your method, right? So in this case, we made a method called getArea, and basically what it did was that it returned the area of like a rectangle or a square based on the 2 inputted values. So if you didn't like look at the slides that we went over last week, it's kind of difficult to explain. But this is kind of like standard. We normally use public static for everything. So if, like for right now, if you're unsure and you didn't watch the video last time, I would just say just use public static for the variables that we write. And then here's the return type. So remember the different types of variables that we discussed, like integer, Boolean, string, character, right? All that stuff was basically like integer, yeah, like integer is a number, double is a decimal number, string is like quotation marks, it's like a word or a character, right? That's basically what this is. So this method here, the method header, we call this, is basically telling us that this method is going to return an integer, right? So when we call it, an integer will be the result of the method, right? And then these 2 are inputs. So we call these parameters. Basically what that means is that when we call the method, we are telling it to use these 2 numbers in order to calculate our stuff, right? So these are basically like placeholders for numbers, right? So let's say, yeah, there's an example here, right? So basically what this is that it's calling the method and we're calling it. So we're basically telling it, hey, can you calculate the area of this rectangle with certain dimensions? And the dimensions are 10 by 2, right? So you're basically telling it to calculate the area of a rectangle that has a length of 10 and a width of 2. And then it's going to return 20, right? Because 10 times 2 equals 20. So that's basically what a method is, right? This is how we create it, right? So we have a header, and then in here is basically what code we want to run when the method is called, right? So in this case, since we're telling it to get the area, we're saying multiply the length by the width, right? As you guys know in math, the way you can return and you get an area is basically multiplying the length by the width. Yeah, and if you don't understand this, let me know. Yeah, and then yeah, so we have a method, and then the kind of complicated part of this whole thing is that you have to call the method in order for it to run, right? Like this code alone here does not work if nothing happens. Like you won't know, like it doesn't run if you haven't called it yet. Like this is just creating it, but after you create it, you have to tell it to run too. So this is basically the part where we tell it to run. So this here is what's known as a main method. It's basically what you see on your Replit, right? So if you guys get Replit open in the meantime, it starts you off with the main method, right? Which is the method right here. Just because anything that's run in the main method specifically will be called, right? The program reads this main method, and then anything called in this main method will be executed. So that's why we had to call our method here. So yeah, so this is called a main method. Okay, cool. That was a lot of information throw at you in like 10 minutes. Yeah, I will just pause for 30 seconds. If you guys have questions on methods or loops, let me know, put them in the chat.
I just want to say something. I feel like a good way to think about methods is like before we were having like 1-line commands. Like we would write like system.out.print, like it's one command that we write on 1 line. And a method is kind of like a bunching of commands. Like it's a bunch of commands together that you don't want to repeat yourself 100 times. So like you kind of put them in a box and you label it, and it becomes like a new command group. Use that. I mean, I'm going to call it command group. It's not technically correct, but if you think about it, like conceptually only. So it becomes like a command group. And now all of a sudden, if you want to like fry a virtual omelet, you only have to write 1 line. You don't have to do 1,000 steps, like get the eggs, heat the frying pan, find the oil, whatever. It's only like one command. It's like you're bunching commands together to make them shorter and more easy to read.
Yeah, so Natalie, you had a question on how do you call a method? So basically, I kind of copied over the code. This is how we write a method. And then this is how we call it. So notice how it's in two separate methods. So this is the method that we just created. And then this is the method that we're calling stuff in, right? So all we need to do is we take this name here. So our name is get area. We write it here. And then in the parentheses, we basically fill in the parameters. So notice how it's the same order, right? The 10 represents the length and 2 represents the width, right? So these are just arbitrary placeholders. And then once the user enters in the specific information for the method will get called, right? So if you try this, it doesn't actually run just because we said return, right? So return is kind of tricky. Return basically means it's returning it to the computer, but not to the display, right? This here is basically a display. So what you would have to do is you would have to print out what was returned by the computer to put it into the display. Yeah. Okay, cool. Okay, so I'm just gonna move on. If you have any questions, just keep typing in the chat and I'll answer them. Okay, so now we're gonna talk about classes. And classes, what people typically use to describe classes is that it's a blueprint for objects, right? And that's kind of a definition that you don't really understand because we haven't taught objects yet. It's kind of like something you have to teach and then you learn objects and then you kind of take your knowledge back to classes and you're like, oh, that makes sense now, right? So classes are basically like blueprints, right? So let's say we have a rectangle, right? And a rectangle is defined as a quadrilateral with 4 right angles, and it has 2 pairs of equal and opposite sides, right? So these are equal and then these are equal here, right? So that can be considered a rectangle's blueprint, right? That is like the standard creation, like cookie cutter creation for how you make a rectangle, right? So you can make many different rectangles from this one definition, right? As we saw before, you can have a rectangle with length 2 and then with length 10 and then width 2. You can also have one with like length 7 and width 13, right? There's so many different rectangles that you can make from this one definition, right? And within each rectangle, you can you can get the perimeter or you can get the area of that rectangle. And it's all going to be different for every rectangle that you make, right? So that's basically a class. The class is like this kind of arbitrary cookie cutter definition of a rectangle. And then the objects are basically like the more specific rectangles that you make, like the ones that you actually specify the dimensions. So like 7 by 2 is an object of this class, right? 10 by 3 is like another object of this rectangle class, right? Because you're making various different rectangles from this one definition. Hopefully that made sense. That's like the best that I have. So this is kind of like explaining in English, and we're going to translate this over. So the 3 components of making a class are constructors, fields, and methods. So these are kind of things that we'll go over in the next slide. Okay, so this is kind of like a brief overview of the rectangle structure. I mean, the class structure, right? So we're going to slowly code this out, but I'm just going to give you like a quick overview right now. So first we name it. So public class, and then this is our name. So this is literally the rectangle class, right? And then we have 2 brackets over here, which basically denote the beginning and the end of the class. So if you look over here, it's kind of the same, right? Here, you're also using class. This is called the main class. And the code within your main class is within these 2 brackets. You see this bracket on line 1 and this bracket on line 10. Those are basically the definitions of the class. So it's kind of like telling you like the class starts here and it ends over here, just so that you're within the boundaries of the code. So we have that. And then these are our fields, which are basically variables. You notice how you're basically making them, you're declaring the type and you're telling the name. So they're essentially variables. And then you have your constructor, which we'll go over in a second. And then you have your method, right? Notice how our method is exactly like the same exact thing that we just made, right? It's called the same way, well, kind of the same way, but it's made the exact same way, right? You have public, ignore that there's no static here, that will be explained later. You have your return type, which is basically telling you that when you call this parameter, when you call this method, the parameter will be an integer, and then you have your name, your parentheses, your bracket, and then whatever code you want to be returned, which is calculating the parameter, right? So notice all the syntax. So you have your semicolons after all of these little lines. You have your brackets after all of this, and then your parentheses here. Okay, so yeah, so the first step, making a class, right? So hopefully you guys have your Replit open because we're going to be coding this class on your Replit, right? So first, public class name, right? So we're replacing this class name here with the actual name of our class, right? So if we go here, what we're going to do is that we're actually going to make a new file, right? So we're going to call it rectangle.java, right? We're calling it rectangle with a capital R just because our class name is going to be rectangle, right? The class name, as you can see here, main, has to match the name up here. And then .java is like the classic. That's how you tell the program that it's a Java file, .java, right? But your class name matches the file name up here. Exactly, it has to match. Or else I think you're gonna get an error, right? So then we're just gonna start. We're gonna say public class rectangle. Hopefully you guys have that on there. Give you a few seconds. So you're gonna make a file, call it rectangle.java, and then you're gonna say public class rectangle. This is basically creating the class on the file. And then within these brackets here is where you're gonna write the code. Okay. Let me switch over. Okay, so now that we have our header created and we have our file created, we can start by making something called a field, right? And a field is basically like any other variable. The reason why we call them fields is because the variables that are declared up here basically mean that they're accessible to the rest of the class, right? So what that means is that the variables can be used throughout the class because their scope, which basically says like what can be viewed by the methods and the constructor of the class, is like out here. Yeah, it's kind of a bad way to explain it, but it's basically saying that these variables have access to the entire class. They can be used throughout the class no matter where you are, right? So we're gonna declare these fields. So we're just gonna call them int_side1 and int_side2. So this is basically creating the variable without giving it an actual value yet, right? Because you're gonna assign the value later. In Java, you can just declare the variable int and the name, and then you can just put a semicolon. And that kind of denotes that you're going to declare that later in the code, right? You don't have to necessarily say like int_side1 = 10. You can just leave it. Okay. So then, now that we've created our fields, we are going to move on, right? So hello to the person who entered. We kind of just talked about classes and stuff. Hopefully, I don't really know how to explain this because you weren't here before, but classes are basically like blueprints, right? So I gave the example before. I'll just quickly go back to Nazira and Natalie. If you guys have questions, put them in the chat. So classes are basically blueprints, right? So let's say you have a rectangle, right? The rectangle is a quadrilateral. That's how you define it. The real definition of a rectangle is a quadrilateral with 4 right angles and 2 pairs of equal and opposite sides, right? That's basically a class. It's defining the kind of classic definition of a rectangle. And then the objects of that class are different rectangles that you make, right? So it can be like a rectangle with the dimensions 10 as a length and 4 as a width, right? That's one object. That's how you make a class. It's basically like putting numbers to the definition. And then you can also have like a rectangle that has dimensions like 5 as a length and 4 as a width. Yeah, so we're just working on creating our class. I'm pretty sure that was a really bad explanation, but hopefully you'll watch the recording. Okay, so after we've made our fields, we are now going to talk about our constructor, right? So this time we're just going to have 2 fields just to make it kind of simple, right? So a constructor is a special method in Java used to initialize objects. I don't know if you guys remember this, but initialize basically means kind of create an object. So the constructor allows you to create an object from the class, right? So our constructor, we say public rectangle, and then in here we have the parameters, right? So this kind of won't make any sense to you until you guys learn objects. But basically what it does is that, I don't know how to explain this without explaining objects. It's kind of telling you, like, when you make a rectangle object, what two numbers do you need to make it, right? And when you make a rectangle, you kind of need to tell the program, like, the dimensions of the rectangle, or else, like, how is it going to know what you want to make, right? So this is basically saying, like, the length will be X and the width will be Y, right? So these are just placeholders for when the user actually inputs numbers to make the rectangle. So this is basically like saying that a rectangle has like two pairs of equal opposite sides, which basically means like one side can be like 10 and then another side can be 4. And it's basically saying, like, when you input, you're going to input 10 and 4 into these. Yeah, just to tell you with that, we'll explain that more when we talk about objects, right? So within our constructor, we're basically setting this number. So the user's going to enter a number, right? So let's say the user's going to enter 10 into here and 4 into here, right? So after these numbers have been entered, the computer, we're going to say side 1 equals S1, side 2 equals S2, right? So basically what it's doing is that it's actually giving this variable and this variable up here a number, right? So we're saying that S1 equals 10, right? And then you're going to transfer that 10 into the field that you made up here. So now side 1 equals 10. That's basically what's happening. Yeah. Okay. I'm going to move on. Hopefully we'll just go more in depth about with objects because it's easier to explain there. Okay. So this is something that might trip you up later, but notice how, so these are our fields. This is our field, and this is our parameter. So notice how we're setting the fields equal to the parameters and not the other way around, right? The red is equal to the blue. It's not the blue equal to the red. It's red equals blue. Okay. And another tip, just to make sure you guys are okay, just don't set your parameter names the same as your field names, right? So these field names are X and Y, but the parameter names here are A and B. This is good. This is what you should do. X and Y should not be the same here, right? Like, unlike this is what you shouldn't do. Like, this is still allowed in Java, but it's not great because it just causes a lot of confusion, right? X, so the fields up here are X and Y, and the parameters here are also X and Y. That's not something you want to do, because if you name two variables the same name, the program is like kind of confused on which one is which. So then you'd have to put like an extra this dot, which is basically saying like this X and Y relates to the ones up here and not the ones over here, right? So yeah, just bottom line, name your parameters different from your field names. Okay, cool. So then we're going to go into methods, right? So methods in your class are pretty much the same thing, right? You basically are just like writing methods for your class, right? For example, I'll just do this example for you guys real quick. So for example, we can add a method that can calculate the perimeter of the rectangle, or a method that can calculate the area, right? So I'll just skip this constructor here. Right, so now we can talk about methods. So for example, to make a method, right, we start with public, and then let's say we want to do, this is the perimeter one, so it's going to return an integer. We're going to say get perimeter, and then we're going to say int length, int width, right? So basically, this is creating a method that calculates the perimeter of the rectangle, right? So this is our method header. Remember how this is the return value, and it's basically saying, like, when you call this method here, it's going to return an integer. And in order to calculate the perimeter, the method is saying that I need to enter a length and a width in order to calculate the perimeter. Right, so we're going to return, so now we're going to calculate the perimeter, which is basically length plus width. Right, that's basically our method created. Yeah, so kind of recap real quick. Fields, constructor should be here, methods. And you can also add another method. Let's say we do public int get area, right? Again, it's going to return an integer. We need length again and width to calculate the area of the rectangle. Then we're going to say return length times width, right? Because that's how you calculate the area. So that's basically methods. It's pretty much what we learned last lesson. And notice how they aren't static. We'll kind of explain that later on. Okay. Yeah, actually, we're gonna do this practice really quick. I'll give you guys a few minutes. Just write as much of this class as you can. Yeah. And we'll quickly go over it. Maybe. Yeah. I'll give you until 1:30. Just write as much as you can, because we're kind of short on time, but also it's good to practice. And here's the attendance that I forgot to hand out. And then here's a copy of the lesson slides. You wanted a reference.
Should we start a new file?
Yes. And just while you're working, I just want to quickly say, like, if you don't understand classes, it's definitely okay. It takes a decent amount of time to kind of get used to it and like why it's actually used. The more you use it and the more you write, the more it kind of like pieces get put together and you kind of realize like what it's used for, but it definitely takes time. So don't worry if you don't get it now, because I just like spat out a bunch of information at you. So yeah, just take some time to process. Okay, I know that was a really short amount of time, but just for the sake of like being able to finish all the lessons today, I'll quickly go over what you need to make. Right, okay. So first, like Natalie said, you want to make a new file. And then you're going to say public class library. So this is basically telling the program that you want to make a library class. So then you're going to have your fields. So our fields are amount of books and pages per book. All right, so that's what we're going to make. We're going to say we're declaring it as an integer, amount of books, and then int pages per book. All right, so these are basically our fields, right? They're exactly like variables. You're just not setting it to a value yet. And then you're gonna have your constructor. Basically, oh, I forgot to mention, but your constructor name is the same as your class name. That's a must. So notice how this is library. This also has to be library up here. So then here, let's take A and P. Because we know that our constructor wants to take the amount of books and pages per book. We want, like, when the user enters and they make their library, that's what we want, right? So then we're just gonna set the fields equal to the constructor parameter, and then pages per book equal to the other constructor parameter. This is like kind of a big if. If you guys don't get it, it's totally fine, because I'm pretty sure I explained it really terribly without objects. And then we're gonna make a method inside your class that calculates the total number of pages, right? So that's basically just a simple multiplication operation. So again, it's public, the integer, because we're returning the number of pages, which always is going to be an integer. And then we're going to say total pages. That will be the name of our method. We don't need parameters because we already have our variables up here that we can just multiply. Amount of books times pages per book. Yeah. So the reason we have fields up here is that we can use them like throughout our method, right? If these fields weren't declared here, then this wouldn't exist. Yeah. So that's pretty much the method done. I mean, the class done, right? So we have our fields, our constructor, our method, which in this case, we only have one, but we can have multiple throughout the class. I'll give you guys a few seconds. Yeah, sorry, what?
Wait, what's the point of the constructor then? Because if you're using the initial integers, amount of books times pages per book, then what's the point of the integers? I mean, the constructor.
Hold your question to like right after this. So I'm just gonna stop my lesson here and then pass it on to Ludmilla because she's gonna talk about objects, which is essentially why a constructor exists. That's why it's kind of difficult for me to explain it now, because you kind of need objects to talk about classes and constructors. Okay, I'm gonna stop my share. Ludmilla, you can screen share.
I will screen share. Present. Okay. Meeting. Can you guys see my screen? I can't see my screen yet, but okay, here we go. Yes, nodding. Okay. So woohoo, objects, Jillian already heavily hinted at this. So yeah, so basically, like, now that we have a class, we don't know like what to do with it yet. So I mean, we know what to do with it. Obviously, Jillian was already talking about this, but this is the idea of like motivating this topic. So we have this class and we want to use the blueprint to like make a house, because like a blueprint does not help you with anything. It helps you with planning and stuff like that, but if you actually need to work with things, you can't work something that you can like manipulate and like a real life object, not just like a plant or something, and information storing, because a class is kind of just storing information about something that could potentially be a real thing, but objects are like actually the real thing that you can now do stuff with. I know this is all really vague, but yeah. So basically this works pretty much the same as when you make variables. We have the like data type, so to speak. Like before we had like integer and string and I don't know, double and whatever. So you would have like a double variable, which is like a decimal variable. So you're storing this data type like of a decimal, like a number with points after it, like decimal places. So in this case, you kind of like making a new data type, which is like rectangle, for example, if you have the rectangle class. So your new data type is rectangle, and you're making a new variable of data type rectangle, which you name using the class name here. So if I wanted to make a rectangle object, I was write rectangle here instead of double or integer or string. And then you write the name of your variable, your object. And then here, this gets a little different. Usually you would just write like 3.5 for a double or 3 for an integer. But here you write new, and then you write the data type again. And then you write the parameters that we had in the constructor. So you're kind of calling the constructor, you're creating a new object and calling the constructor here all on the same line. Because in order to create a new object, you have to like reference somehow, like in order to create a rectangle, you can't have a rectangle with side length 0 and like width 0, like it's not a real object. So you have to give in these parameters in order to actually create something, because without parameters, you can't create a real thing. So it's kind of like 2 lines in one. You might actually be able to do this in 2 lines. I've never tried it. Actually, you might not. I don't know. You can try it, and if you get an error, then we'll know. But yeah, it's convention to write it like this. Yeah. So yeah, the parameters of the object match the parameters in the constructor. If you write like different data types than the parameter data types that you gave in the constructor, then in Java will give you an error, because you can't try to fit, like what Java does is it takes what you wrote here and it stores it in this, like it tries to assign the value to these variables. And if you gave it a string when it was asking for an integer, you can't assign a string value to an integer data type, so it gets all messed up and throws you an error. So this always has to match both in number of parameters and data type with this. I don't know if Jillian mentioned that already, but yeah, I just wanted to, very important. So again, we have the kind of already said that, but yeah, it's just syntax, just you have to memorize it.
So basically, to answer your question, Natalie.
Oh, it's your question.
It's kind of like telling you exactly what you need. So a constructor is basically a blueprint for making an object, right? I think Ludmilla kind of skipped over on the example real quick, but like if you see at the bottom, wait, go back. If you see at the bottom, go.
Oh, sorry, here?
Right. And then click one more time.
One more time?
Mm-hmm.
Oh,
so if you
yeah.
see at the bottom in the green box, right, it says 10 and 7. So that's basically saying 10 is S1 and then 7 is S2, right? So you're basically setting the side 1 and side 2. So that's kind of why you need a constructor, because let's say you had a double as one of those parameters, then in your object making, you would have to also have a double. It kind of has to match exactly. So it's kind of like the format for making an object of a rectangle class.
Yeah. Okay, wait, yeah, okay. I didn't see it because my little bar was on top of the green part. Okay. Okay, so we discussed, I know methods was like the last lesson, but the idea is now that you have an object, you can use the methods on something, because when they're in the class, you can't use them. They're just like this abstract thing. Like I have a car, I can accelerate with the car. It's not like a real, like a concept. It's not, you can't actually use it on anything. With an object, like you can think about cars and you can go to automotive engineering school and talk all you want about cars, but you can't actually accelerate a car unless you buy a car and you sit in it and you actually press on the gas. So you need an object, you need to create like an object in order to use the methods that you planned for this object. So this is then very simple. We have a certain syntax for calling the method on the object. You name the object, and then you write dot, and then you write the name of the method, and then you have parentheses. If you have parameters for your method, you write the parameters in the parentheses here. The same thing for parameters applies. It has to be the same number of parameters. They have to be in the same order. They have to have the same data type, etc. But that's pretty much it. So this is all you do to call methods on objects. It's pretty. Is that good so far, by the way? I don't want to like rush. Okay.
Why is the thing in the front?
What thing in the front?
Why is it rect1?
Because we named our rectangle rect1.
Oh,
so this is the name of our
yeah.
Okay. So yeah, so just it's the same thing. If we named it Bob, we would write bob.getParameter. Yeah, it's just the name of the. Yeah.
Also, if you notice, getParameter is kind of a method of the rectangle class. So when you make an object, the object has everything in the rectangle class. It's its own thing, right? So when you call getParameter, you have to tell the program like which rectangle you want to call it on, right? Because sometimes you can make more than one object, right? So we can also have like rectangle rect2 equals new rectangle with the parameters like 6 and 5, right? So then you'd have to tell the program that you want to get the parameter of rectangle 1 and not rectangle 2. So that's why you kind of have to specify like which object you're calling the method on. Also, sorry, I keep interrupting.
No, it's okay. Yeah. So obviously you can't call a method on an object of a different type. If I have a get perimeter method and I try to call it on, if I have a get perimeter method in a rectangle class and I try to call it on a car object of a car class, obviously it's not going to work because the same concept, first of all, obviously as a human, you think the same concept of perimeter does not apply to a car as does to a two-dimensional shape. But in addition to that, even if it did, even if I had a triangle class, if I did not define a get perimeter method for the triangle class, even though a triangle conceptually has a perimeter, I can't call an object from the rectangle, I can't call a method from the rectangle class on a triangle object. The methods you call have to be from the same class as the objects that you are calling them on. Yeah, okay. Feel free to just yell if you have, questions. Okay, so now we'll get to the static modifier. I mentioned this, I think, when in the chat when Jillian was talking about it. It doesn't really make any sense until you get to objects. Basically, this took me, actually, I honestly learned this, like, I would say 3 months ago, even though, I mean, I know like I should have known it before because we've been doing Java since, and I've been on the team since my sophomore year, but it's like, it's a very weird, I think it's important to know because it makes things easier, sort of like conceptually things make more sense when there's not all kinds of words floating around that you really don't know what they mean. But I guess saying that I learned it 3 months ago, it doesn't come up super often, so like, but I think it's a good concept to like have down pat. Anyways, so the static modifier, sometimes we write static and sometimes we write nothing. So we write like public int blah blah, and sometimes we write like public static int. So kind of you either write static or you don't write anything. When you don't write anything, like the default of Java is that it makes it what we call an instance variable. I can write that in the chat maybe. Oh, I didn't mean to caps lock, whatever. So an instance variable, or not variable, like an instance method or a static method. So it says it like we're here. So if it's static, it's associated with like the class as a whole, not like the single object that you create. So every single, wait, I believe every single, one sec. Yeah, so every single like object you create, this applies like conceptually to every car object ever. A static method applies to every car object ever. An instance method is specific to the object, the individual object that you create. So if I have a car that's like blue and I have another car that's red, this color variable would be an instance variable, not a static variable, because it's specific to each individual car that I make. However, if I have like a Tesla class, all of Tesla cars are electric. So the like electric true or false variable would kind of be static because it's true for all cars under this class. They're all electric. So we're not like, this is something that changes for the entire group of objects and not for an individual object. I don't know if that, so here, whenever new object is created, the static variable doesn't reset because it's the same for everything. But if something like a color, like a factory is going to produce cars of all different kinds of colors, they might all be like a Honda Civic, but they're different colors. I don't know if that makes sense. Jillian doesn't look very happy, but I think
Can you put a class within a class?
No. How would you mean? Like what prompts you to ask that question?
Because like you said the static variable, so you could, I was wondering if you can like use it to describe something within a variable. I don't know.
Okay, wait, we only talk about static in like terms of methods. So this also applies to variables. If you create field variables, I might have not clarified that, sorry. If you create field variables, you also sometimes write public or private in front of them. And you also sometimes write static, or you write instance, which is just like writing nothing. So this same thing applies for classes. for methods. So there will be methods that apply to an entire class of objects, and there will be methods that apply only to specific objects in the class. For example, if I have a method that says, like, if I have a blue car, the lights are going to be different color, and like the headlights are going to be different color, then my blue car headlights method will be specific only to cars that have the color blue. I would make it static if it were specific to all cars, if it were non-specific. So I guess when you, like, the thing with you don't really have a class within a class, because a class is, you have enough space to define everything, just to be specific enough. I mean, I guess using the word colloquially, like, you have a class of objects within a class, like you have a class and then you have a subsection of objects for which certain instance methods may apply, and a class of objects within this real class for which, am I getting way too conceptual
No,
here?
yeah, that makes sense. So if you make something like the rectangle, right? If you list a static method, let's say all rectangles have right angles, right?
Yeah.
And then what's the other one? Like if you don't
Instance.
put it, instance, if you don't put static in front, it becomes an instance would be like, it's a square if it's all sides are equal.
Yes, I think that, right, Jillian? Because
I would
a
say
square can be a rectangle.
I would say
not
kinda.
all.
You're thinking about it kind of like conceptually to the definition. The way I kind of learned what static was that by what we mean. Okay, so let's say you wanted to count the number of rectangles that you made, like the number of objects that were made from the rectangle class. You would use what's called a static variable, right? Because every time you make an object, you can just add one to that variable, and the variable will not reset. So if the counter variable wasn't static, every time you make an object, the counter variable will start at 0, right? But if we make the counter variable static, whenever we make an object, the variable will increase by 1. So let's say we make 10 rectangles, the counter variable will be 10 if it was static. But if it was not static, the counter variable will be 0, because every time we make an object, the variable will just reset if it wasn't static. Now that I'm explaining it, I realize I was kind of confused.
Oh, so if it's not static, then it resets to apply to the specific object.
Yes,
but if it is static, okay.
That's like the exact definition of static.
That's a very good application. Yeah, I didn't remember that. I was doing pure concept. But yeah, how we really use it is what Jillian described. Yeah. So the fact that it resets is probably going to be useful for AP Computer Science, because they try to trip you up on the exam with like static and, oh, if we make this static, is it going to be the same for every variable, or is the variable going to be empty or something? But I think it's good to keep the conceptual thing in mind, because when you're building classes, you really need to know, like, am I going to make this method static or instance? Like, do I want this to apply to everyone? Do I want it to reset every time? Yeah. Okay. I'm gonna keep going. Oh, okay. Yeah. So same thing with field variables. Like I said, you can make variables static as well. Yeah, that's pretty much it. I feel like I might have said everything on the first slide. Let's see what's left. Yeah, exactly. So a static method can only access a static variable. Sometimes you will make a method and you'll get an error and it'll say like, oh, we can't access a static variable from we can't access an instance variable from a static method, I believe. Static methods can only access static variables. Instance methods can access everything. Instance methods have everything. Static methods only have a line to static variables. They cannot access instance variables, because if you have something that's static that applies to everything, no matter what, an instance variable may vary. And then if you have like this conceptual static variable here, it can't necessarily access the blue or the red or the purple color of the individual car, because it's on a whole different like level. Am I explaining this right? Yeah. I don't know if this makes sense.
It's kind of like the nitty-gritty of static. Like,
Yeah.
you don't have to completely understand it now, and I think we're also kind of like running out of time.
Oh yeah. Okay. Yeah. Okay. So I think what Jillian said was a pretty good. Okay, we're already at practice. Oh yeah, but I still need to do user input. So should we do the practice? I feel like we can do the practice later. I'm gonna do user input first, and then we can go back to practice if we have time. Does that sound good? Yes. Okay. Okay. So I talked all about objects and I loaded you with a bunch of conceptual things. So now we're gonna do an example to make sure like that this makes more solid sense. Okay, sorry. Okay, so we have user input. The motivation for user input is probably pretty intuitive. Every time you type something into your computer, every time you enter your password for Facebook, you are inputting something into the program as a user through your keyboard, and the program has to somehow receive what you are typing in. Obviously, you're not typing directly into a console or a application program which the computer is running. You're just typing into the graphic user interface, and the code has to get what you're not typing like directly into Replit. You're typing like through a filtered thing, and somehow they have to, like Mark Zuckerberg has to reach his hand out and get your data somehow, like without you typing it directly into his personal laptop. So user input is like it's the code extracting data from the user. Like the user oh my God, this is so bad. The user gives data to the code without typing directly in the program. Yeah, I hope that makes sense. I'm sorry, it's late for me. Okay, so an example of an object, like we use the scanner class, we call it, like it's an example of a class where using it as an example because it's used very often, not so much in robotics, but in courses, I guess, that you take. We kind of don't use it in robotics because we do everything with the code, and because we're not having some kind of third-party user, when we need to change things, we change them directly in the code. But you can imagine that somebody who's creating like some kind of Facebook, for example, obviously everybody's grandma who uses Facebook doesn't want to deal directly with the code. They want to deal with the pretty user interface with the pictures on it. So you need to be able to have them communicate with the code to do things without actually typing Python or Java or whatever. So I'm gonna explain how to use the scanner class and scanner objects to do this, and with this you'll understand more of like how classes and objects work. So I already said this. Oh yeah, let me just quickly, I'm gonna jump to the API in like 1 minute. I'm just 1 sec. Actually, no, I'm gonna do that right now. Okay, so click on this link. Woohoo. Bring us to a link. I don't think I actually need my Replit. X that out. Okay, what do you want? Yes, I accept all cookies. The EU always makes me do this. Every time I'm in the EU, I have to accept all the cookies. It's kind of dumb, but whatever. Some kind of like thing they have about data, whatever, saving. Okay, so this thing is called an API, what I just clicked on. This is like, there are a lot of resources in Java. You don't write everything yourself. I think there was an example with the time class. Actually, we skipped that example, but the idea is not everything you use, you write yourself, because as you can imagine, sometimes people need to do pretty complex things. And I don't want to write a new class with new methods every single time I want to set a timer or something in Java. I don't want to write a time class and get into like the insane specifics of how my computer measures microseconds. I want to use a time class that somebody has probably already written in the 1990s. I don't want to write it all myself because it's going to take me forever and hundreds of pages of code. It's not good. So the API is basically like a kind of dictionary kind of thing where all these like classes that people have already written and that work are like open source code for you to use. So there will be a time class where you can measure. There will be classes to create rectangles. If you guys have ever used Python, like the turtle class where you can draw things with pixels, there's tons of classes. And the idea is it's just pre-written code, and you can create these objects out of these classes that people have already written without having to write anything yourself. You don't even have to copy and paste their code into your console. All you do is you use an import statement to import their code. So you're not typing it out, or you're not like copying and pasting their whole class into your code. You write the word import, and then you write like the path. I don't know if you guys can use paths on your computer, like, oh, desktop folder 1, file 1. So you write the path to this class, and you write the word import next to it. And that lets you use the class that somebody else has already created. So in this case, java.util.scanner is the path to the scanner class, which helps us, which somebody already wrote God knows how many years ago, which helps us get user input from a person using the computer. So you have to write this at the top of your code, because if you don't write it, it's never going to import, because how would it know what to import? Yeah, we use a lot of imports, especially in robotics, a lot of imports, because a lot of things you just can't write yourself. We can't write every single little tiny method that has to do with like the deep electronics of motors. Like we just can't write them ourselves. So we use them that are open sourced. Yeah, and there's a specific API for like robotics. This is like the general Java API. But there's specific APIs for different things. There's like a Facebook API if you want to write code that backtracks off of the Facebook code. Yeah. Okay, I'm gonna try to hurry up because I'm like way behind. Okay, so we create a scanner the way we would create any object. We write the class name. I think it should be written. Yeah, so scanner is the name of the class. We write our name, input might be the name of our variable. And here we write system.in. This is like a parameter. The idea is that the user is inputting data into the system. This is like, it would go, this system.in goes into the constructor of the scanner class so that it understands like that we're trying to input data. Yeah, so there are a lot of methods in the scanner class for storing this. So you can store the next integer that the user types and ignore the next, oh yeah, application programming interface, yeah. Oh yeah, yeah, it was good that you gave them like, so yeah, so all of these methods will be written, like documented in the API, and you can like, they'll explain them in plain English. So they'll say next is when you just want to take whatever the user writes next. Next line is when you want to take whatever is after an indent that the user writes. So these are pretty self-explanatory. Next Boolean means that you only take true or false. If you call next Boolean, if the user writes like 5, 6, 7, 8, true, 3, 4, 9, it's only going to extract true because all you were looking for was the next Boolean. You're ignoring all the integers and all the other like garbage that the user has input because you're looking only for a specific data type. But this is explained on the API, so I don't even, you guys can look at this yourself and yeah. So yeah, so we can store obviously these methods, they will like return the next integer. So we can store this into new integer variables so that we can like keep, so we can have enter your age and somebody writes 90. And then we store whatever the user has inputted in a fresh variable so that we can keep it so that it doesn't just fall off the console and we never see it again. Yeah. Yeah.
Wait, if you go back really quickly.
Oh yeah.
So the main reason why we chose to explain classes is that user input's important, but also it kind of shows you how we can make an object, which is basically what we described. And also the API is pretty important for like knowing how to use it, right? So if you look at the screen right now, in red, it says scanner scan equals new scanner system.in. So that's basically an example of making an object. We're making an object of the scanner class, right? So the class name is scanner. The name we chose to name the scanner is scan, and then new scanner, and then we put our parentheses and the parameter. So I don't really want to explain the parameter right now, but that's basically how we made an object, if you remember from like 10 minutes ago, right? And then we called a method on the scanner object, which is the next red box you see, and we just stored the value that was returned from that method inside a variable. So that's basically like making an object and then using a method of the object. Right, and also really quickly, like if you guys go to the API link that I sent in the chat, the reason why we showed that to you is because, like Ludmilla said, in robotics, we kind of use APIs to kind of figure out what methods we need to use to make the robot do something and what method it'll return and what parameters it needs, right? It's kind of telling us like how we use these methods. So yeah, Ludmilla is like on the screen, you can see there's like a method summary, and that's basically saying all of the methods that are within this package are right here. Right, so it's kind of telling you like the different methods that you can use, and you can kind of, and how to use them. So it's kind of like, if you read it closely, it looks complicated, but it's basically plain English on how describing like how certain methods work and stuff like that. So yeah, real quick, when we do Java and programming stuff, we kind of and like robotic stuff, we kind of like look at the API and we figure out like what we need based on the definition of the method, and then we kind of implement the method.
Yeah, so I mean, yeah, it's pretty self-explanatory. So this is a find inline method. This is the parameter. This is the explanation, and this is the return type. And they do the same thing for the constructors. Yeah. So I don't think we have time to go over the practice. I mean, should we, Jillian? I
I
mean,
think really quick, I don't think you should do this practice, but I think you should go back to
the other one.
time.
Okay.
Also, the time class is a class that you made. It's not like a specific package. We don't use the package, so.
Yeah, no,
Just
I
like-
in this case, yeah, but I meant like in general, like I was just using it as an example with the time, like yeah.
Yeah. So,
yeah.
people who are here right now, I guess
If you wanted,
put in chat.
yeah, in the chat. Chat is good.
Yeah, just make an object of the class and call get seconds. We'll give you a few minutes. I know we're over. I just want to like make sure this is down first, and then we're good. I'm also gonna resend the attendance in the chat. Just make sure to fill it out if it happens.
Okay. Okay, so the first line is correct with the exception of missing a semicolon. But can you guys see my screen, or you can only see the tab? Can't see the whole screen. Okay, but you guys can see the chat. So yeah, so the first line is correct. So yeah, so to call I think this was, let me go back actually. I think I had it somewhere. You write the name of the object, and then you write dot, and then you write the name of the method, and then the parameters. So in this case, you would write time1 dot get seconds, and then instead of you don't put the name of the object in the parentheses, you put the name of the object first, and then you write dot get seconds. So it's not really like math where you write f of x and you write because like with f of x in math, you only have a variable, you're not calling it on something, and in Java you're calling it on something, so you have both the variable in the parentheses, but the thing you're calling it on goes at the beginning. Oh yeah, feel free to type it out. Yeah, exactly. Yeah, you can call obviously whatever you want.
Is there anything in the parentheses in the call?
Wait, let me look at the method. I didn't actually look at it. No, because there's no parameters here, right? So for get seconds, there's no parameters. So you wouldn't put anything in the parentheses, but that doesn't mean that you would put the name of the object in the parentheses. You always put the name of the object and then dot, and then if there's no parameters, you just leave the parentheses blank. Yeah, okay, wait, so like that, but without the last curly bracket. So with a semicolon, I don't know, that might've been a typo. But yeah, you just no curly bracket, because you're not like making a new class. We only use curly brackets when we're like defining blocks of code and stuff like that. In this case, it's just a simple command, so we only put a semicolon. Yeah. So I think you guys have it down. If there's any questions, feel free to ask them. But that's kind of it.